onward to activity 12.2, water level in the aquarium. All right, so number one, a large aquarium should contain 10,000 liters of water when it is filled correctly. It will overflow if it gets up to 12,000 liters. The fish will get sick if it gets down to 4,000 liters. The aquarium has an automatic system to help keep the correct water level. If the water level is too low, a faucet fills it. If the water level is too high, a drain opens. One day, the system stops working correctly. The faucet starts to fill the aquarium at a rate of 30 liters per minute, and the drain opens at the same time, draining the water at 20 liters per minute. So what we should be asking ourselves is what information is probably most important. So let's highlight a couple things. We know that if it overflows, it's at 12,000 liters. The fish will get sick at 4,000 liters. And then the faucet fills up at 30 liters per minute. So if it fills up, that's a positive amount. And it's draining at 20 liters per minute. If it's draining, that's a negative action. So what we need to determine is, for part A, is the water level rising or falling? And how do we know? Well, if it's not working correctly, it's rising at 30 liters per minute. Okay, so that's a positive action. So that's a positive 30, right? But then it's also draining at the same time. It's draining 20 liters. Ah, cat. So it's draining 20 liters per minute. Draining is a negative action, so that's negative 20, right? So we need to figure out if it's rising or falling by looking at the difference of the two. So positive 30 plus negative 20 equals positive 10. So even though it's rising and draining, it's filling up 10 liters per minute. So that is our rate at which the tank is filling up. Now for part B, we need to look at how long will it take until the tank starts overflowing or the fish to get sick. Okay, so we know that it overflows at 12,000 liters, and we know that they get sick at 4,000 liters. Our starting point is 10,000 liters, so we need to figure out how many more liters it needs to fill up before it overflows, or how many more liters when it gets down to a level that's unhealthy for the fish. So we have to find the difference. So I'm going to take 10,000, sorry, not 10,000, 12,000, because that's how many liters it takes to overflow. Subtract the starting point, and the difference is 2,000 liters. So it needs to fill up 2,000 liters for the water to overflow. So that is the distance, that's the end point. So if I use my equation, the distance equals the rate multiplied by time. My distance is just the end point, which is 2,000, equals the rate at 10 liters per minute, and I'm going to multiply that by the time. And remember, to find the time, it's the distance divided by the rate. So 2,000 divided by 10, that equals 200 minutes. 200 minutes, that's a long time. For some reason, I was thinking of like a normal aquarium in a house, but I guess a 10,000 liter aquarium is really large. So 200 minutes for it to overflow. We need to do the same thing. Oh, that's not what I want to do. We need to do the same thing now for a water level that gets them sick, which is 4,000 liters. So it starts at 10,000. I need to subtract to 4,000, which is a difference of 6,000 liters. So it has to drain 6,000 liters. We have to figure out how much time it's going to take for it to drain 6,000 liters. So same thing, distance equals the rate multiplied by time. My distance is 6,000. Whoa, super zoom. Sorry about that. Equals 10 liters multiplied by time. If I do the division, the time equals 6,000 divided by 10. The time equals 600 minutes. All right, so it should take them 600 minutes, or the aquarium, 600 minutes to drain, which makes, well, that's not what I wanted either. Which makes sense. It should take longer to drain because it's still filling up. All right, so we just did division by two numbers, and we used the same rate because it's still filling up 10 liters a minute. All right, moving on to number 2. A different aquarium should contain 15,000 liters of water when filled correctly. It will overflow if it gets to 17,600 liters. All right. So one day there's an accident and the tank cracks in 4 places. Water flows out of each crack at a rate of 1/2 liter per hour. So for each crack, it's 1/2 liter. And I have 4 cracks. An emergency pump will refill the tank at a rate of 2 liters per minute. How many minutes must the pump run to replace the water lost each hour? All right, so first we need to figure out how much it drains. In the 4 places. All right, so 1/2 represents how much it drains for each crack. And there's 4 cracks. So 1/2 multiplied by 4 is 2 liters per hour. Right? So that's how many liters it's draining per hour with the 4 cracks. We also know that to refill the tank at a rate of 2 liters per minute. So how many minutes must the pump run to replace the water lost each hour? So if it replaces 2 liters per hour, and we know that it fills up 2 liters per minute, then it's only going to take 1 minute to fill up the 2 liters that it drains. Right? Because if it's draining at 2 liters per hour, but it fills up 2 liters per minute, then after 1 minute, it's going to fill that 2 liters that it lost already. So how many minutes must the pump run to replace the water that it lost each hour? Well, it needs to fill up 2 liters once every hour. Because it's draining 2 liters per hour, but after 1 minute, it just fills it right back up. So it only needs to fill up the 2 liters every hour. Boom.